Hello everyone and welcome back. Again, something a little bit different today. I thought, maybe I'll watch another YouTube video. I feel like at this point, I've only watched the Naruto 20 years anniversary one, which you should go check out right now. Hopefully I'll remember and I'll put that info card right there for you. But anyway, it's a little bit different. This is, how do I pronounce this? I can't pronounce it. Hopefully you guys can see it right there. Let me look. Yeah, just right there, how to terraform Mars with lasers. It's a video we're watching. It was just released kind of recent, and I actually love these videos. It's what I haven't seen, so I figured, let's enjoy this ride together. Let's go.
Mars is a disappointing hellhole lacking practically everything we need to stay alive.
No, he's
It looks
pretty
like
right.
we'll only ever have small crews spend a miserable time hidden underground. Except we could terraform it into a green new world.
Could we?
But to solve the planet's problems, we first need to make it worse and turn it into oceans of lava with gigantic lasers. This isn't a far-fetched science fiction tale. Terraforming Mars is possible on the kind of timescale our ancestors built great monuments in. If humanity solves some of its pressing problems and ventures into space to expand into the solar system, this may not be that far off. Okay,
Just gotta turn my volume down a little bit.
Mars quickly? Well, it's complicated.
All right, I'm excited. I'm a space nerd. I don't know if you guys know that.
Mars is dry and has no soil to grow anything. Its atmosphere is too thin to breathe or protect us from radiation, giving you a high risk of cancer. So to turn it into a new home for humanity, we have to give it a proper atmosphere similar to Earth's. It should be made of 21% oxygen, 79% nitrogen, and a tiny bit of CO2, at an average temperature of 14 degrees Celsius and under 1 bar of pressure.
I don't know how much 14 degrees Celsius is.
We have to create oceans and rivers, and then the ground has to be weathered into fertile soil to host living things. Then we need to install a biosphere on the surface and prevent it all from being undone by installing protective measures that can stand the test of time. It is difficult.
That sounds pretty hard.
But
Oh man, an ad. I even scrolled through this whole video.
Challenge 1, the atmosphere.
Okay.
Some 4 billion years ago, Mars had a nice oxygen-rich atmosphere and was home to vast oceans and rivers. It held on to it for several hundred million years before it got blown away. Ultraviolet rays broke down the atmospheric gases and then the oceans until they were swept away by solar winds.
Okay. Makes sense.
Today, Mars is a dry, barren wasteland. Luckily, a sizable portion of the water is frozen in deep reservoirs and in the polar ice caps, enough to create a very shallow ocean. And enormous amounts of oxygen are bound as minerals in the Martian rocks, like the oxygen in the iron oxides that give the planet its rust red color, as well as carbon dioxide in carbonates. To free these gases, we need to reverse the reactions that lock them away by using thermolysis, which occurs at temperatures as high as on the surface of the Sun. In short, we want to melt the surface of Mars. The best way to do that would be to put lasers in orbit, aiming their beams down on Mars.
I don't see how anyone would approve this, though.
The most powerful laser today is the ELI-NP, able to produce beams of 10 petawatts of power for a trillionth of a second.
Jesus Christ.
To melt Mars, we need a laser twice as powerful that runs continuously. The easiest way is to use a solar-pumped laser that can be powered directly with sunlight. At its core are metal-infused glass rods that absorb energy and release it as a laser beam. If we build an array of mirrors in space about 11 times the size of the United States, we can focus enough sunlight onto them to melt Mars. Let's do it. As the lasers hit the surface, about 750 kilograms of oxygen and some carbon dioxide emerge from every cubic meter of rock melted. If we are efficient, our lasers only need to melt through the top 8 meters of the surface to get enough oxygen.
Oh, that's it. Just the top 8 meters of the entire planet.
The skies would be shrouded in storms, while the ground would glow red hot, crisscrossed by currents of lava. Tireless laser beams sweep over the landscape, leaving trails too bright to look at. After they pass, the ground cools quickly. A strange snow falls. The ashes from all the elements that solidify as they cool down, like silicon and iron. Mars is still a cold planet at this point. A happy side effect of this inferno is that all the water in the polar ice caps and even deep underground rises into the sky as hot steam, forming clouds that rain down over the entire planet. They would wash out the nastier gases from the atmosphere like chlorine and carry away harmful elements that accumulated on the surface. In the end,
Now
they
we
would
have
form
water.
shallow oceans, saltier than on Earth. We might need to do an extra
Saltier?
cleanup afterwards. It would take about 50 years of continuous lasering to
Oh
create
my
our oxygen
God.
atmosphere. We could use this opportunity to dig deeper in some places to create the basins for salty oceans or rivers and spare some landmark features like Olympus Mons and Valles Marineris. We're not done though.
This sounds
The resulting
incredibly
atmosphere
expensive.
is nearly 100% oxygen and only 0.2 bar. It's hard to breathe and very flammable. To make it similar to
Yeah.
Earth and a lot safer, we need to add a lot of nitrogen, which Mars is sadly lacking. We have to import it.
From where?
The ideal source is Titan, a large moon of Saturn, covered in a thick atmosphere
Okay.
that's almost entirely nitrogen. We just have to move 3,000 trillion tons from the outer solar system to Mars.
Yeah, that's
While
it.
that's not easy, it is doable.
It is
To process
doable. That's
that
why I
much of
like this
Titan's
video.
atmosphere, we have to construct giant
We could
automated
technically do
factories on
all
its
of this
surface,
right
powered
now
by
with the
our lasers
technology we
to suck
have.
in the atmosphere and compress
It would be
into a
hella
liquid.
expensive,
This gets
very
pumped
time
into
consuming.
bullet-shaped tanks, which a mass driver
But it
shoots
is
all
kinda
the way
cool.
to the red planet, where they explode and mix with the oxygen.
Sweet.
We've already been able to send individual missions to Saturn
Okay.
in just a few years. With enough resources,
So in this
it should be
scenario,
possible to
we are,
complete the task within 2 generations. Of course, it would
Uh,
be much
what,
more
a solar
convenient to have
species at this
nitrogen
point?
left over from terraforming
Going all over the
Venus on the
place.
side. We explained this in detail in another video. So, about a century after the start of the terraforming
Venus might be a
process,
better place
we
to
have
go
a
to.
breathable atmosphere that has
For,
the
like,
right
humans to live.
gases. If the liberated CO2
Have, like, floating
isn't enough
cities in
to warm it
Venus.
up to temperatures we can stand, we just add some super greenhouse gases. Mars at this point resembles a black marble from all the cooling lava, spotted with growing oceans and red patches where the old surface remains untouched. It's still a wasteland, no better
there-
than a desert on Earth.
But there is
We
water.
need to fill it with life. Challenge 2, Biosphere.
Oh man, and then you'd be
Installing a
importing
biosphere
plants
on
from
a
an
new planet is
entire
very
other
difficult.
planet.
Unexpected interactions between species or sudden diseases can destabilize it to the point of collapse.
Yeah.
We would probably begin by seeding our young oceans with phytoplankton. Without competition, it would bloom rapidly, filling up the oceans to become the bottom of their
Oh
classic
man,
food
yeah,
chain.
no one would ever
They can
sign
be
off
followed
on
by
this.
tiny zooplankton, then by fish, maybe even sharks and whales. If things go well, life in the oceans will thrive.
I just don't see
Life
this
on
being
land
able to
is
happen
harder.
at all.
Plants need nutrient-filled ground to sink their roots into, but most of the surface is the congealed remains of lava and ash. We could wait for thousands of years for water
Yeah.
and wind to grind it down into finer sands, or try to do it manually. But we
God.
want to be quick, and we have a big laser. Turning the beam on and off in rapid succession would cause the ground to quickly heat up and contract, which breaks it into smaller and smaller pieces.
These
Add a
lasers are
bit of
just doing
water
everything,
and you
huh?
get a sort of dark mud. Into this mud, we can
Also,
mix
I hate to
fungi
say it, but
and
these lasers would be
nitrogen-fixing
used as
bacteria.
weapons on Earth, by the
They're
way.
able to absorb nitrogen
They exist
and
now,
convert
it's too
it
late.
into nitrate compounds to feed plants. The first plants we want to bring are native to volcanic islands on Earth, since they're perfectly suited
Yeah,
to the
makes sense.
laser-blasted Martian landscape. Eventually, the enriched mud becomes the foundation for grasslands and forests. In Mars's lower gravity, trees can become very tall very fast. Their roots gather the nutrients they need and then dig deeper to turn more rocks into soil, forming a self-sustaining ecosystem.
Okay.
At this point, we can slowly introduce more plant varieties, insects, and animals. Not
Things would be
mosquitoes, though.
so different.
The
I
new
feel like they just
biosphere
end
needs
up
to be
there.
maintained to prevent it from falling out of balance. If plants grow too quickly and absorb too much carbon dioxide, the planet cools down too much. If key species die out, we could see populations collapse faster than they could recover.
Yeah.
On Earth, other species would move in to fill the void, but our Martian biosphere is not as flexible.
Yeah.
It takes hundreds, if not thousands of years before Mars becomes a stable environment. But eventually, the planet will have the potential to sustain large human colonies. With
if you
air,
think about this
water,
in the
and
long
food
run,
available,
would
we
be
can
an
finally
incredible
call
feat for
Mars,
humanity.
Black, blue, and green, our home.
It would be incredible.
A giant volcanic island
This is
in
incredibly
space.
doable. I'll
Will it last, though? Challenge 3, the long-term future. There is a problem we haven't addressed. Mars's core does not produce a magnetic field, so it doesn't have enough protection from solar radiation or cosmic
Interesting.
rays. This becomes dangerous for the
Oh,
long-term
God.
health of Martian populations.
Oh my
So,
God.
as a final step, we need an artificial magnetic field. It doesn't
Artificial.
have to be huge like Earth's. It just needs to deflect the solar wind enough so that it doesn't touch Mars. The easiest way is to construct a magnetic umbrella far ahead of Mars that splashes the solar wind to the sides. A big superconducting ring powered by nuclear facilities is all it takes.
Yeah, that's
it
it.
would orbit at the Mars-Sun L1 point, keeping it constantly in between the Sun and Mars and protect the new atmosphere. And that's it. Terraforming Mars would take some work, hefty resources, and probably a century or 10, but it would be the first time we've lived in a home designed and shaped solely by us and for us. The first step towards our future among the stars. The first step that we can already take down here on Earth is learning more about the physics and biology needed for such a project. To help you with that, we've created a series of lessons to build your fundamental understanding.
Again, I don't think it's ever going to happen, though.
Made in collaboration with our friends at Brilliant.org, these lessons give you a deeper understanding of the topics from our most popular videos, from supervolcanoes to black holes to climate science. Brilliant is an interactive learning tool that makes maths, science, and computer science accessible with a hands-on approach. Because we know that to really learn something,
I'm gonna let this play, by the way.
Do it. Think of each lesson
I'm already
as
watching
a
their
one-on-one
video.
tutoring version
Shout out to
of a
them.
Kurzgesagt video. In our latest lesson, you'll learn more about how Mars lost its atmosphere and how we might protect a terraformed Mars from suffering the same fate. Brilliant has thousands of lessons to explore, from maths-based topics like algebra and probability to the concepts behind algorithms and machine learning. And with new lessons added each month, including ones from Kurzgesagt, you'll always find something fascinating to learn. To get hands-on with Kurzgesagt lessons and explore everything Brilliant has to offer, go to brilliant.org/nutshell and sign up for free today. There's even an extra perk for Kurzgesagt viewers. The first 200 people to use the link get 20% off their annual membership, which unlocks all of Brilliant's courses in maths, science, and computer science. We love seeking new horizons with our research. Brilliant will be the catalyst to expand the limits of your knowledge.
Which you should always be doing. Well, that was a great video, actually. Oh man, I held my tongue and I probably shouldn't have. Now I don't remember what I was going to say. Oh. I don't remember exactly what I was talking about. But maybe I'll get there in my ramblings. Like I was going to say, no one would sign off on this project. Just the idea of blasting like more, like not even just one laser, like I'm gonna say like 10 lasers and just blasting the fuck out of Mars's surface so it's turning to lava. Yeah, no one's gonna sign off on that. And you need like the big governments too, because it takes 50 years of just that. 50 of just that. I would have to be like a world effort, and especially with some stuff they were talking about, like transporting, there we go, stuff from Titan and having it be shot to Mars, which is probably the best idea, like for money wise, so you don't have to keep launching ships. But then that means you have to get to Titan, which we've never done. Well, I guess it doesn't have to be man, it could be machines, which I'm like 90% sure that we've sent probes and stuff to Titan. Don't quote me on that though. But yeah, you could, I mean, what they're talking about, they could easily do it, but there's already plans in the works to have like the shitty underground, probably not even underground, but SpaceX is doing stuff. I believe NASA wanted to do stuff too for like permanent human colonies. So if they want to do that, I don't see them trying to terraform Mars, which would be the best thing, in my opinion, for us to do. Like long run for a good human colony. The other thing is you'd have to bring in a lot of species, like a lot. I don't know how you would do that. You could bring like a couple and then have them hopefully breed, but then still, like, it's just a lot. It'd be a very, very delicate balance. Even like with just releasing certain plankton, like if it's just one species of plankton, we have no idea what that could do. It could change things so much, so fast. And then I mean, it makes sense. So you start the very smallest bits of life, you know, like you do need like little bacteria and stuff like that for anything, you know, like I also have, rambling on. I have a terrarium for my crested gecko, and I have an aquarium for some guppies. And yeah, you have to start with like little tiny microscopic life forms to like slowly build up the ecosystem for it to be like bioactive, is what people normally call it. I'm looking off screen right now because I'm looking at both those things there. They're right over there, just off camera. But yeah, it's not easy. Like they said, if one thing went wrong, the whole thing is fucked. Like it's such an immense project, but I'd like to think we'd be planning it out the whole way. So say like in that 50 years, we're just blasting the fuck out of the planet. During that time, like he said, you also carve out where some oceans would be, some rivers. Try to leave some good monuments intact. As much as you can, you're already melting the surface, so people are going to argue what the fuck that matters. But anyway, you can do that. But then again, who decides where that is? How would you decide where some oceans are or some rivers? People are not good at cooperating. And whoever is doing this would want full control of the planet. So then it gets into some weird topics about like corporations and stuff running it and it being like a corporate world almost. Or what countries would be there? Would they be their own countries? It's a very weird process, but shoot, I guess we're already going through that right now anyway, in real life. So again, fun video. Made me think about a lot of things, but I enjoyed it. As always, you know, guys, just gonna give you the spiel. Like, comment, subscribe, and again, if you fucking thought it was stupid, you comment how bad you hate it. And then maybe I'll change stuff in the future. I don't know. We'll see. Check out my Patreon for 4 weeks of early 4 weeks of early content. That mainly just being, what am I gonna say? The Dragon Ball episodes. That's the main bread and butter of the channel right now. This is just some extra stuff to splash in there. Maybe bring some new people so they can check out the Dragon Ball reaction series I have. Also, check out my gaming channel, link in the description down below, and I will see you guys next time.